Hi, my name is Marcus Trice, and I'm doing a video response to an assignment, week 8 assignment. This is number 2. I did one for the first one. This is the final project, and that's why I'm actually doing a video again. This way I can actually show, because it's asking for actual illustrations. This is for BBS 16401, Basic Ballistics. And again, I am Marcus Trice. So the first question on here, provide an overview of trajectory, wind drift, recoil, velocity, and accuracy. So trajectory is basically a projectile leaving the muzzle of a given elevation angle follows a ballistic trajectory whose characteristics are dependent upon various factors such as muzzle, velocity, gravity, and aerodynamic drag. The ballistic trajectory is referred to as the bullet path. Basically, when a bullet is fired from a firearm, as it leaves the muzzle, it's followed its path to its intended target. And that trajectory can be affected by many things: the weight of the bullet, the charge in the firearm, even though if you're firing from an elevated position to a down position, the bullet and how it's shaped can have an impact also on trajectory. So that is trajectory. The next one on there was, take a look here. The next one was wind drift. Wind drift is an interesting phenomena that affects bullets. So when you're firing a bullet, it is the exterior environmental changes on the bullet. So as the bullet's leaving the muzzle, you can have a crosswind from the west that's pushing on a bullet. Lighter bullets are more affected by wind drift rather than heavier bullets. But so if you have a .22 and you're aiming at a target and you have a 5-mile-an-hour wind, you know that you're going to have to adjust for that wind drift. You're going to have to move it to the right in order to compensate for the push of the wind that's going to the left, if you want to hit the actual target that you're aiming at because of wind drift. People will utilize wind drift when they're talking about shooting, precision shooting with a scope, and they will adjust for wind drift. The next thing is recoil. So recoil, the momentum acquired by the gun exactly balances the forward momentum of the projectile and the exhaust gases coming back, according to Newton's third law, known as conservation of momentum. Basically, when a cartridge is fired and the bullet, the pressures from the gases in the chamber and the exiting bullet creates rearward forces, either in this, well, obviously if it's a blowback on the slide, if it's not a blowback and it's bolt action, you will feel more of that recoil in the rifle, and it's a felt recoil, but it's also a produced recoil and a felt recoil by the shooter. So, and what was the other question? The other part on here was accuracy. So, accuracy is basically a firearm's accuracy is the ability to hit exactly what one is aiming at. The precision is the ability to hit the same place over and over again in repeatable fashion. That's the common term of accuracy, but for our purposes, it's basically when we are shooting a firearm based on the particulars of that firearm and the particulars of the ammunition or the cartridges that are produced. So there's many things that can affect accuracy. The caliber, the powder, the primer, the firearm at question, if it has a short barrel, if it has a long barrel, its particular rifling, and ultimately, and even damage, if you have a damaged muzzle, it all can affect where that bullet will actually impact the target. So if you're shooting at a target and you're trying to hit the center, you want to be as accurate as possible, and so all of those other factors can have an impact on your accuracy. So the accuracy is, poor shooters would like to blame it on the firearm, but sometimes the shooter can have an impact on accuracy. Velocity. Now velocity is very interesting. It's the speed of the bullet, basically. So you can have many different velocities based on, again, the cartridge type, the amount of powder, and as we just learned, the primer could probably have a slight impact on the velocity. The velocity is basically the bullet speed as it's leaving the muzzle, and that velocity can change over distance. The velocity can be impacted by the length of the barrel. So you may have a cartridge that has a known velocity at say 1600 feet per second out of a 16-inch barrel, but then when you have a shorter barrel, say like a 9-inch barrel, and you're shooting that same bullet with that same load, bullet weight, and so forth in cartridge, you will end up losing velocity because of the lack of built-up pressure in the barrel. And I think that handles that first part. And how does this affect the firearms that you're handling? With all of those, obviously, every one of those plays a part in every particular firearm that you may use. If you're using a rifle for long distance, that's something that trajectory, wind drift, and accuracy would be very specific to. If you're using maybe a firearm like a handgun, you would obviously, it would be accuracy and recoil, maybe, if somebody was recoil sensitive. So each one of those has an effect on the gun that you're using, which should have an effect on the shooter. And that's how those different items affect either a gun or you as the shooter. And so you have to take that into consideration: the trajectory, the wind drift, the recoil, the velocity, and the accuracy. So as a firearms person, you would want to make sure that you understood those and knew those if you were reloading. If you were instructing people on firearms, on how to shoot a firearm, you would need to know those, because you would be picking particular firearms for particular purposes with those in mind. Let's see. Also, identify the components of a round of ammunition. Use illustrations for your identification, and that's why I have here. So let's just start off with the basics. So you have a casing, all right, a brass casing or steel casing. Then you will have a primer, and I hate to pull these out. You'll have, without having them fall out of the tray, you'll have primers that will go into the bottom of a casing. And then in the casing, you will have powder. Okay, a certain level of powder. And then you will have, now this is a 22 caliber necked casing. This is 5.5, oh actually this is 223. And this is a 30 caliber. It's not for the same cartridge, the case, but it's illustrative purposes. Here you have a projectile, a bullet. This bullet is jacketed. It has some cannulas on it, and this one has a polymer tip. So all of these together, the bullet, the casing, the primer, and the powder is what constitutes or makes a cartridge. Okay, the next question is describe how to work up a load. So the easiest way to work up a load is to have a book. Have a book and know know what your purposes are, and find in the book, say, okay, I'm going to be shooting a particular type of caliber for a particular type of reason. So you'd find in a book like this, you would find your bullet caliber, your bullet weight, and then the powder that you would be using. then you would, usually it gives you a range from low to much higher, and you would start a little bit under the midpoint with a particular weight of powder to get a particular velocity, feet per second. You would take it to the range, you would use a chronograph, and you would test those rounds to see if you're meeting or you're getting those velocities out of that particular cartridge that you're made. If you're not getting that particular velocity, then either you would be changing the bullet weight, or you could change the powder. So you would work your way up until you got to the particular velocity that you want. It could either be high velocity for a long distance, or it could be low velocity for possibly maybe suppressed firearms. So that is how you would work up a load. You would do one set, take it to the range, or maybe 2 sets or 3 sets. Take it to the range and test each powdered weight. And as we learned this week, maybe even a different primer, a manufacturer of primer maybe. And that is how you would work up your load of a particular cartridge. And again, that's for a particular need or requirement. The next one up here is describe how to properly seat a primer. Now that's an interesting question because it depends really on what you're using. Now obviously when you're seating a primer on a case, you want it below the base of the case or flush with the case. You don't want it poking up, you don't want it crooked. And obviously you want to make sure that you have the right primer for the right case opening orifices. And also it depends on the actual way that you're priming it. If you're using a hand primer, you know, obviously you're going to set your primers up and you're going to put the case in and you're going to seat it by hand, and you're going to feel in your hand, you should, if you've been doing it, you should feel the proper pressure. If you feel something odd or fighting, obviously it's not seating well, and then you would inspect it. On a progressive, you're I don't want to say you're at the mercy of the actual unit, but you are. You would set it up, and then you would test and make sure that the primer is being seated properly, and then you would go through 100, and then you would check and make sure that A, you still have primers, and then B, that it's still seating it correctly and that your equipment is clean. Now I skipped over one. It says describe how to build a projectile. And I'm going to use, again, my projectile here, and this is something very interesting. You have 2 different ways as if I were to do it. I would cast a projectile. I would, a lead projectile, I would take lead, melt it, put it in a casting. It would cool. I would then have a cast bullets, which I would swage and lubricate to the particular caliber size, or even the particular caliber for my particular rifle, if you wanted to be that accurate. Another method is to swage. So like this one is jacketed in copper. So as we learned, you take a lead core and you would swage it, and then you would swage the jacket to the bullet, and so you would have a jacketed bullet that would come in different cylindrical points, flat nose, hollow points, soft points. This one is, I would call it a hollow point with a polymer tip in it. So that's how you would build up a projectile. And then let's talk about the safety precautions needed when working with ammunition. And the big one is eyewear, eye protection. And it's huge. When this is for reloading in particular, you know, ammunition in itself has its own precautions as far as, you know, dropping them, shaking them, keeping them near heat, electromagnetic forces and things like that. Heat's the big one, and moisture. You don't want to, obviously you don't want to get your ammunition wet. And chemicals. You don't want to have, you could potentially spill a chemical on ammunition, and it could actually have an adverse effect on that ammunition, maybe the performance of it. But anyway, the big thing here is eyewear, eye protection, and proper clothing, and even ear protection. You could be reloading a blank case, putting a primer in it, and you can have a detonation. And and if you're pointing it at you, which which you shouldn't if you're hand loading the primers. You should be always putting it away. But or even on a press, you could literally have a detonation and it could shoot debris in your eye. So it's huge. And another big thing is you don't want to have if you've got gunpowder out, you don't want to have any open flames anywhere. And I'm going to mention it. Always keep your gunpowder lid on, because one of the things you can do is spill it, and then that could be a problem. And then also you want to be very careful with your primers. You want to make sure that you're not dropping them places. You want to make sure that you're not crushing them, and you want to make sure that your equipment is clean and not defective in any way, because you don't want to be loading primers into a piece of equipment that could potentially set off that primer. Okay, so we've talked about the safety precautions. We've talked about how to properly seat a primer. We've talked about how to work up a load, and now we've talked about how to build a projectile, i.e. swaging or casting. And then also we've illustrated the the different components of a cartridge. And then we've talked about trajectory, wind drift, recoil, velocity, and accuracy, and how that has an effect on or how you should view it with different firearms that you may be handling. Again, so this is my week 8 assignment for BBS 100 6401. I've tried to go through this relatively quickly because when I upload to YouTube, you only have a little bit of time. But anyway, I want to add one last thing, is that I really enjoyed doing these types of projects, learning about reloading and the components. Being very interesting. Thank you very much.